that had the encryption stripped, and you can stuff them into IDA Pro, and it'll it'll show you the call stacks and the data flow and all that stuff. And so for folks that are familiar with that, you have that level of access. I'm a lazy Java developer, and so I prefer the DEX stuff. But one thing that is different about the iTunes applications, or things that you get from the iTunes store, is they come encrypted, to the device. And it used to be like fairly straightforward. You can run, and we'll show an example. Is you can run a OTool against the binary, and it'll say, hey, my encryption starts 4,096 bytes in, and it lasts for however long. You could pull it up in a debugger, set a breakpoint to be just after where the encryption starts, and basically tell the thing to run. It would run through its decryption process and then like drop you out just after it had finished decrypting the text segment, and then you could dump the memory from that text segment, do a little spacey, buffery, whatever stuff, and then you've got an application that's essentially been stripped of its encryption. That's a little bit trickier now. And I haven't checked back to see if that had been defeated yet. Like eventually, I assume that it will be. But an interesting thing is that the default apps on the device, your mobile Safari, your maps, and all that stuff, like those actually don't come encrypted. So if you jailbreak your phone and you go into the normal, like the default applications that are on there, those aren't encrypted, and so you can go and pull a tremendous amount of information about those guys. Did anybody do any iPhone development? Right, a little bit. How do you like that dev environment? That was real. Yeah, it was a real space age for like maybe 1995. Yeah, that's true. That's true. The built-in static analyzer is nice. And so again, like with any binary, you can do like kind of goofy stuff where you run strings on it and dump things out. And one of the things that is also interesting from an Objective-C standpoint is Objective-C is a superset of C code. So any valid C program ought to compile out under the Objective-C compiler and with the extensions that they've got. So if you call like for object my thing and you call do stuff and the args are ABC, like that gets basically translated around to in the C code to the equivalent of I'm going to call this object message send with this and a string for the method that's being called, and then var args stacks the stuff up after that. So just like we were able in the to go through the DEX code and find all the method calls that are being made, you can pull out some of that information, but because it's in the just like a raw assembly file, it's less you're less able to go through and and see all that, see the context surrounding that unless you pull it up in an IDA Pro or something like that. So you can, the OTool command for folks that are familiar with doing Mac development, this also works for iPhone stuff, but you can do things like OTool -L, and that shows all the load commands, and the load commands are where you also see the information about the encryption for those binaries, so that you can see where the encryption starts and how long the encrypted area is. And for unencrypted apps, you can easily disassemble this stuff into ARMv6 assembly and do the same type of stuff that you do that you would do to like the Java DEX stuff. If you run it on an encrypted binary, you actually just get garbage. All kinds of invalid instructions and opcodes and stuff like that. So like the net result for iPhone applications is they're certainly more obscure because of some of the platform stuff with the encryption, because of the language they're written in, the way the binaries are built. You don't get as much information, so it's more obscure, but it's not, at the end of the day, that's not going to actually make you more secure, because you can still retrieve a tremendous amount of information. And so just looking at in mobile Safari, we can look at all the stuff that you can pull out of that. Yeah, so you can see all the stuff that mobile Safari is trying to talk out to, and let's see. As well as the the stuff that they're talking to on Bing, the stuff they're talking to on whatnot, and so even in for the platform specific stuff, you can still the status of stripping the encryption for the more recent, iPhone 4 binaries, or in iPhone or iOS 4, but but you know, that's a problem, you know, much like DRM. That's something that's going to fall eventually, right? So you can't just, I don't think it's safe to, as an iPhone developer, to make an assumption that that stuff's not going to be made available. So, you know, as a developer, what can a developer do? This is something where threat modeling is, I think, increasingly important for these types of applications that have more kind of more interesting architectures, data flows, and whatnot, because it's more opportunities for things to go wrong, and you really do need to know where the data is going and what's being stored. Just like the city folks found out, hey, we accidentally stored this stuff on the device, and it's going to, it gets like transferred back when we do a backup of the phone, and so now it's on the desktop and going wherever it is from there. Because they didn't pay attention to that and got them into trouble. You got to be careful what you store on the device. PCI, HIPAA regulations. It's really interesting to me to see all the, like, there's a lot of innovation going on these mobile, iPhone applications that support like doctors and other medical stuff. I think it'll be interesting to see when like the FDA steps in and makes a determination to say, well, if you're making these types of decision based on that mobile application, we're going to consider that to be a medical device, which means that your dev process and all that stuff has to be FDA auditable. So that's maybe more of a question for David Rice. That's kind of in his patch. You got to be careful consuming third-party services. All these things talk out to Yahoo. They talk to Google. They talk to all these third-party services. And so just like in any situation where you're pulling in data that you don't. Where you can't, where it's not data that you have shaped. When it crosses that trust boundary, you've got to validate it. You've got to make sure it gets treated properly, and also, it's important to understand that that these web services, these are not things that are going to be hidden that folks aren't going to find. These are the types of things that it's going to be easy for an attacker to track down. From a security standpoint, like the real challenge that I said is find out about the smartphone projects that are going on in your organization. Because this is something, it's new enough, it's cool enough, it's often coming out of an R&D group or the office of the CTO, which I suppose is what I run at Denham Group. Or it's something the marketing people are going out and procuring, and so they're getting procured in non-standard ways, and so security's got to play catch up to go and track down this stuff. And it's also something like you need to know the security, like how does deploying the smartphone application, how does that change your organization's security posture? What data is getting stored on the device? That's important for you to know. What services are you consuming? How did you increase your organization's attack surface? I've got links here. Obviously, the slides and stuff will be available. I've got links to all the different tools that I talked about there. And so, if you're developing smartphone apps, these are some of the things that I've used. I've got a Perl script that automates a lot of the analysis to crack things open and to make all this stuff available. I'll stuff that up on the web as well.